Okay, we're going to talk about tree diagrams today. And there's two examples of tree diagrams on this screen. What is a tree diagram? Well, a tree diagram is something that uses branches to connect and show all the possible combinations that could happen with an event. So we're going to be using branches to show the connections. Branches. Not branches, but branches. All right, first example. Stephanie has a spinner labeled with the colors red, green, and blue. She also has a number cube that's labeled 1 through 6. Create a tree diagram to show all the possible combinations or outcomes that could happen when Stephanie spins the spinner and rolls the number cube one time. The first piece of information we know is that there is a spinner and it has 3 sections. It's labeled with the colors red, green, and blue. So that's what I'm going to start out this tree diagram with, is the colors on top. Red, green, and blue. It's going to be connected to the numbers that are on the number cube, and it says the number cube is labeled 1 through 6. 1, 2, 3, 4, 5, 6. And that's going to be on each one of these sets. And we already got through saying that the thing that made tree diagrams different than the rest is that the objects are connected with branches. So the color red is connected to all the numbers available on the number cube 1 through 6. Now I need to do that same thing with green. Connect it with all the numbers, and then the same thing with blue. Show the connections with the branches from the numbers up to the color words. And when this is done, this would be our way of showing all the connections or outcomes. When I want to know the total number of outcomes there are that are available, which is what this first question is, how many different possible outcomes are there when Stephanie spins and rolls? I can either count all the branches, or I can do what we were talking about earlier, is taking the colors and multiplying it by the numbers, and it's going to tell me how many total outcomes there would be. So 3 times 6 is 18. Now if I'm just counting, this is how I get it. 1, 2, 3, 4, 5, 6. I have 6 here, plus another 6 here, plus another 6 here. So 3 groups of 6 is 18. The next question wants to know how many outcomes will be red. Well, that's pretty easy. Here's the red. All of these together make red. That means there's 6. Then the next one wants to know how many outcomes will have an even number. Even numbers are 2, 4, 6, and 8. Let's make sure everybody knows that. Okay. 2, 4, 6. There's not an 8. It only stops at 6. So 2, 4, 6. And then again with the last set, 2, 4, 6. When I count those up, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different outcomes that could be even. All right, the next one already has the tree made. It says that Jack is going to order a sandwich for his lunch at his local deli. They have 2 types of bread, 3 types of meat, and 2 types of cheese. The tree diagram below shows the possible outcomes Jack can order for his lunch. Again, the important information, I have 2 types of bread, 3 types of meat, and 2 types of cheese. It's already created for me. If I follow the path, white bread, okay, white with ham and cheddar, white with ham and Swiss, white with turkey and cheddar, white with turkey and Swiss, white with chicken and cheddar, white with chicken and Swiss. So that's how you read it. Over here in this outcome column, it's just how you could list. If I put these larger and I follow the path and then I write on it, I could have white bread with ham and cheddar. I could have white bread with ham and Swiss. Still white bread, but now turkey and cheddar. White bread, turkey, Swiss. White bread, now switch to chicken and cheddar. White bread, chicken, and Swiss. And then I could do the same thing, but then switch to the other type of meat. So that's how the table would work out. The questions below, it says, what is a shortcut method to find the total number of outcomes in any situation? So the shortcut method is just find out how many there were in each category. So I have, again, 2 types of bread, 3 types of meat, and 2 types of cheese. It's just simply multiplying them all together. 2 times 3 times 2. And that is going to be 12. The next question says how many total outcomes are possible if he picks 1 meat, 1 meat, and 1 cheese. And basically that's the same thing. After you multiply, the answer you get is just 12. Now the next question, I'm kind of running out of room, so I'm going to move this up. This one says how many outcomes have cheddar cheese. So when I look through here and I'm going to count every time I see cheddar cheese, I could put a dot beside it maybe. If I zoom in, every time I see cheddar, 1, 2, 3, 4, 5, 6. Okay. And then the last question says, how many sandwiches have turkey? You have to be really careful not just to count the times you see the word turkey, but you have to connect the branches that come out of turkey and put all those together. So I'm going to count that in a different way. I'm going to count that 1, 2, 3, 4. So I have 4 sandwiches that can have turkey.